This is the video for Module 14, Section 3.6, about graphing linear inequalities in two variables. A linear inequality in two variables is an inequality that can be written in one of the following forms. So the way that all four of these look the same is that they have an x term and a y term on the left side, a constant term c on the right side. Now they can either have a less than or equal to, or a greater than or equal to. And the a and the b, the coefficients of the x and the y, can't both be 0. Now an ordered pair would be a solution of a linear inequality, just if it makes the inequality a true statement. So here's an example. In this one we have the linear inequality, x minus y is greater than -2, and we have three ordered pairs that we're looking at. The ordered pairs 0, -1, and 1, 2 are solutions, and the way we would know that is if we substituted those values in for the x and the y in our inequality. So for the ordered pair 0, -1, if we substitute a 0 for x and a -1 for y, and then simplify on the left side, we end up with a +1. And since 1 is greater than -2, this is a true statement, and that means that the ordered pair we had is a solution. We could do the same thing for the ordered pair 1, 2. If we substitute 1 for x and 2 for y in our inequality, 1 minus 2 is -1. -1 is greater than -2, so this is also true. Now for the ordered pair 1, 4, what we'll see if we substitute those values in for x and y are that on the left side we end up with -3, but -3 is not greater than -2, so this is false. And that means that 1, 4 is not a solution, where the other two were, because those two made the statement true. Let's look at some more examples of this. Here we have the inequality 2x plus 4y is greater than or equal to 6, and we're testing both of these ordered pairs to see whether they would be solutions or not. So let's look at our first ordered pair. So we're just substituting 4 for x and -1 for y in our inequality. Oops, 6 there. So this gives us 8 minus 4, which is 4. The question is 4 greater than or equal to 6? It isn't, so this is false. And that means that this ordered pair is not a solution. Let's look at our other ordered pair, -3, 3. So here we have -3 for x and +3 for y. That gives us -6 plus 12, which would be 6. Is 6 greater than or equal to 6? This one is true because the equal is included here, and 6 is equal to 6. So this is true since we could say that 6 is equal to 6. So in this inequality, if we only had a greater than and not a greater than or equal to, then this would be false. But since we do have the equal to, it's true, and that means that this one is a solution. Let's do one more example of this. So here we have the inequality 3y is less than x minus 3. We're going to test the point 0, 0. So we're substituting 0 for y and 0 for x. So on the left side we end up with 0. On the right side we end up with -3. Is 0 less than -3? No. This is false, which means that this point is not a solution. Now let's look at the ordered pair -3, -1. So we're substituting -1 for y and -3 for x. That gives us negative 3 on the left side, and negative 3 minus 3 on the right side would give us negative 6. Is negative 3 less than negative 6? No, it isn't, so this is false, which means that this also is not a solution. Now we're going to look at how to graph a linear inequality. So for step 1, what we're going to do is look at our inequality. If we replace the inequality symbol with an equal sign, then we have a linear equation. What we're going to do is graph that linear equation, and that will give us the boundary line for our solution. Now, if our inequality is a less than or equal to or a greater than or equal to, in other words, if it includes the equals, then we'll graph our boundary line as a solid line. If we just have a less than or a greater than without the equal, then we'll graph our boundary line as a dotted line. Step 2 is that we're going to choose a test point which is not on the boundary line. We'll substitute the values from that ordered pair into the original inequality and basically determine whether that ordered pair is a solution for the inequality or not. So we'll be determining whether the resulting statement is true or false, just like we did in the last couple of examples. Now, if it ends up that our test point ordered pair is a solution, then we'll be shading the half plane that contains that test point on our graph. If the test point from step 2 is not a solution, so if it gives us a false statement, then we'll shade the opposite half plane. So we'll shade the half plane that doesn't contain the test point. Let's go through a problem. So we want to graph the inequality x plus y is greater than or equal to 2. So step 1 is that we're going to graph the related linear equation. To get that linear equation, we're just going to replace our inequality symbol right here with an equal sign. So we want to graph the line that goes with the equation x plus y is equal to 2. And remember, all we need to graph a line is 2 points. So we can plug in some easy numbers for x and y and get our 2 points to graph. So let's use 0 for x. If we plug x equals 0 in here, then we have 0 plus y is equal to 2. That just gives us y is equal to 2. Now let's plug in 0 for y. That gives us x plus 0 is equal to 2, and we end up with x is equal to 2. So now we have 2 points that we're going to plot, and those are 0, 2, and 2, 0. So 0, 2, we would start out at our origin and just go up 2. And for the point 2, 0, we're going to start at the origin and go to the right 2, and then we're not going either up or down because the y is 0. So there's our point 2, 0. Now we're going to graph the line through those 2 points, but before we actually graph it, we want to know whether we're going to graph it as a solid line or a dotted line. And that depends on what our inequality symbol was. Since our inequality is a greater than or equal to, this means that we're going to graph it as a solid line. So there's our line. So now our step 2 is to choose a test point and remember our test point cannot be on the boundary, so it can't be anything on this line, but we can choose anything else on either side of the line. A nice easy point to choose if it's not on the boundary line is the origin, so the point 0, 0. So let's choose that one for our test point. Now what we're going to do is go back to our inequality, and we're going to see whether this point is a solution of our inequality or not. So we're substituting 0 for the x and 0 for the y. That gives us 0 on the left side. So we have 0 is greater than or equal to 2. Well, 0 is not greater than or equal to 2, so this is false, which means our test point is not a solution. What that tells us is our solution has to be on the opposite side of our boundary line. So here's our test point over here. We know now this is not a solution. So that means that nothing on this side of the line is a solution for our inequality. And that means that we're going to shade the opposite side of the line. So again, what we were doing over here was shading the half plane that does not include our test point. Okay, let's look at another example now. We have the inequality 2x plus y is less than 5. Again, for step 1, we're going to graph the line that's related to our inequality. All we're doing is replacing our inequality symbol with an equal sign. So we're going to graph this line. And let's think about right away the fact that we have a less than here. So we're going to end up graphing our boundary line as a dotted line. So let's get a couple of points to plot. If we start out by using 0 for x, and that gives us 2 times 0 plus y is equal to 5. And we end up with y is equal to 5. Then let's try using 1 for x. So if our x is equal to 1, then we have 2 times 1 plus y is equal to 5. And if we subtract 2 from both sides, that gives us y is equal to 3. So our 2 points that we can plot are 0, 5 and 1, 3. So 0, 5, we would start at the origin and go up 5. And for the point 1, 3, we start at the origin and go to the right 1 and then up 3. And now we want to graph a dotted line that goes through those 2 points. So there's our boundary line. Now for step 2, we're going to choose a test point. And again, the only requirement for a test point is that it's not on the boundary line. So here, since the origin is not on our boundary line, that would be a nice test point to choose. So we're going to determine whether the point 0, 0 is a solution of our inequality. It means we're substituting 0 for x and 0 for y in our inequality. That gives us 0 plus 0 on the left side, and we still have 5 on the right. Well, 0 is less than 5, so this is a true statement. That means that we want to shade the half plane that does contain this point. So we go over here and look at our graph, and we can see where our point 0, 0 is. So we want to shade the same side of the line that the 0, 0 is on. So we're shading this side of the line. So there's our solution. Here's another example. So for step 1 here, we're going to graph the line that we get by replacing our greater than symbol with an equal sign. And since we only have a greater than and not a greater than or equal to, we're going to graph this as a dotted line again. So now let's pick 0 for x, and that means we're substituting 0 for x in our equation. Then if we divide both sides by 2, we have 0 over 2, which is equal to 0. That gives us y is equal to 0. What that means is that the origin is one of our points, because this gives us the point 0, 0. This also means that in order to get another point to plot, we can't pick 0 for y or 0 for x. We have to come up with a different value for one or the other. So let's just pick 1 for the y. So that gives us x is equal to 2, and that gives us another point to plot, which is 2, 1. So our 2 points on our graph are 0, 0, and for 2, 1, that means we go to the right 2 and up 1. So there's our other point. Now we're going to plot a dotted line going through those 2 points. So there's our boundary line. Now for step 2, we're going to pick a test point. And remember what we said about our test point, it can't be on the boundary line. Since we already know that 0, 0 is on our boundary line, we can't use that point this time. So we can pick any other point on the graph as long as it's not on the boundary line. And the easiest way to do this is just to pick a point that is pretty far from the boundary line so that you're absolutely sure it's not on the line. Let's pick this point up here, which would be the point 0, 6. So we're going to plug that in for our x and our y in our original inequality. So we have 0 is greater than 12. That's false. That means that we're going to shade the opposite side of the line from where that point was. So we're shading this side of the line down here. All right, so there we have our solution. One more example. In this one, notice that our inequality is just y is less than or equal to 2. There's no x term there, but this is still a linear inequality because it does have the y term in it. So for our first step, we're going to replace that inequality symbol with an equal sign. And since it was a less than or equal to, that means that we're going to graph this as a solid line. So remember, when we have a line like this that either doesn't have an x term or doesn't have a y term, that means that the term is missing can be any value, but the other variable has to be a certain value all the time. In this case, we have y is equal to 2. So that means that every point on this line is going to have a y value of 2. So no matter what we pick for x, our y is going to equal 2. So we can just put in a couple of different numbers for x, say 0 and 3. And now we have 2 points to plot. So we can plot the point 0, 2 and the point 3, 2. So for the point 0, 2, we start at the origin and go up 2. So there's our point 0, 2. And then for the point, we're going to go to the right 3 and up 2. And now we're just drawing a solid line that goes through those 2 points. So this is going to end up being a horizontal line. So we have our boundary line. Now for step 2, we're going to pick a test point that's not on that boundary line. And notice again, we don't have the origin on our boundary line, so we can use that as a test point again. So here's our test point. I'm plugging in 0 for x and 0 for y in our inequality. We don't have a place to plug in the x because there wasn't an x term in that inequality, but we can plug in 0 for the y. That gives us 0 is less than or equal to 2, which is a true statement. That means that we're going to shade on the side of the line where the test point was. So we're shading on this side of the line. So there's the solution for our inequality.